Good evening, everyone. So, welcome to my YouTube channel, Math Saptram. So, today we are going to see 12th lecture on sequence. Today we will study subsequences of a sequence. Okay. So, subsequence, what are the subsequence? Let A and be a sequence. If this sequence Nk is an strict is a is strictly increasing sequence, strictly increasing sequence of natural numbers. It means I am writing in bracket n1 is less than n2 and n2 is less than n3, and this is continuation nk, and this will go up to infinity. Then the sequence, then the sequence a n k is called subsequence of then the sequence is called a subsequence of the sequence an. Okay. So there can be infinitely many strictly increasing subsequence of natural number. So there can be infinitely many subsequences of a sequence. Okay. So for the even note that note that this A to N is called even subsequence of an, because we are taking even terms only, and this is strictly increasing sequence for natural number. Similarly, we call this sequence 2n minus 1 is called odd subsequence of a. Okay. So example, it will be clear by example. Example. Example 1. So I am taking this sequence. This, this is the sequence. So if I will take this one, 1 upon 7n, then you see that this is subsequence of this sequence. Okay. If I can take this one, 5n plus 1, this is also subsequence of this sequence. Okay. So, so this is, now you see this one, 1 upon 2n. This is even subsequence. And this is odd subsequence. Okay. Now, note that 1, 1 upon 3, 1 upon 2, 1 upon 5, 1 upon 6, and so on. This is not subsequence of, this is not, this is not a subsequence, this is not, this is not a subsequence, subsequence of, because you see that 1 upon 3, 1 upon 3 by comes by putting 3 in 1 upon n, or 1 by 2 we achieve by putting 2 in 1 by n. Okay, but 1 by 3 comes 1 by 3 comes before 1 by 2. Okay, so this sequence 2, but by definition of subsequence 2 will be greater than 3, which is not possible. Okay, which is not. That is why this is not subsequence. Okay, okay, okay. So example 2, I am taking this sequence. Okay, so what are the, so this is -1. This is odd subsequence of this. And what is even? Even subsequences. Okay. Now prove a theorem. Okay, theorem. Let an be a sequence, then the following statements are equivalent. First, an converging to L. It means an is convergent to L. So we are right in this symbol. When the sequence is convergent to some number, we write like that. A is tending to L. It means an tending to L means, what is the meaning of this? An is convergent and limit limit an is L. This is the meaning of this. Second one, for every subsequence for every subsequence A and K, we have we have We have A and K, A and K tend to L. It means every sequence is convergent. Same meaning. Third one, A to N converging to L and A to N minus 1 tending to L. It means even and odd subsequences are convergent and their limit is L. Okay. So let's see its proof. We need to show that all these statements are equivalent. So first assume that, so first implies true. So we are assuming that first is true. So we are writing first implies true. So here we assume that first is true. So let A and K be a subsequence of A n. Now let epsilon greater than 0. Since A n converging to L implies there exists capital N belongs to N such that A n minus L less than epsilon for all N greater than capital N. Now, now this sequence is strict, strictly increasing sequence of natural numbers. Natural numbers. So this implies, so there exists, so there exists N k naught belongs to N such that K n naught will be greater than capital N. Now, then A n K minus L will be less than for all N K greater than. This follows from star. So why this is happening from star? So let's say this star. Because subsequent terms are nothing but the terms of the main sequence. So we know that this is greater than n naught. I'm taking n k. So this is finally greater than n. So this will happen because by star. So we have a n k minus l less than epsilon for all n k. So we got a natural number, fixed natural number for this is happening. So what is the meaning of this? So meaning of this is a n k is convergent and convergent and limit of tending to infinity, A and K is L. So this implies A and K converging to L. Okay. So 2 implies 2 implies 3. This is trivial because because for every subsequent A and K, we have every subsequence A and K converging to L. Since A to N, A to N, and A to N minus 1 are also subsequences of A N, we get we get A to N converging to L and A to N minus 1 converging to L. So this is proof. Okay. If every sequence is converging to L, even and odd sequences are also subsequences of AN, so they will also converge to L. So this is trivial. So 3 implies 1. Let A to N let A to N converging to L and A to N minus 1 converging to L. Okay, since so let epsilon greater than 0. Let epsilon greater than 0. So A to N converging to L implies there exists capital N1 belongs to N such that A to N minus L less than epsilon for all N greater than capital N1. Let's say this 1 and and A to N minus 1 converging to L implies there exists capital N2 belongs to N such that A N minus 1 L less than epsilon for all cap N greater than capital N2. So I am taking maximum of N1, N2. So put N is equal to max of N1, N2, and this will belongs to natural number. Then, then, then for N greater than capital N, we have N greater than N1 and N greater than N2. So I am taking AN minus L. So this is A 2N minus L if is even and N is greater than capital N. So that will be less than epsilon and it will be 2N minus 1 minus L less than epsilon if N is odd and greater than capital N. So there are two possibilities. Either N is odd or N is even. If N is even, we can uh, take care by this one and by equation 1. If n is odd, we can take this one by equation 2. So n can be even and odd also. So this is done. Okay. Okay. So I can write like this. So this is I would like this. So this is am minus l less than epsilon if m is equal to 2n is even. Okay. And m greater than capital N. This is am minus l less than epsilon if m is equal to 2n minus 1 2m minus 1 is odd and m is greater than. Okay. Okay. So by this one, what we have, so by this one, what we have, an minus l less than epsilon for all and greater than capital N. So what is the meaning of this? The meaning of this is an is convergent and limit of an is L. So what is the meaning of this? An convergent to. So this is proved. Since one implies two, two implies three, and finally three implies one means we get all the statements the statements are equivalent. So this is proved. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you on next lecture.